Roppongi Hills is a monumental achievement. And yet, Sky City will go so much farther, transforming the same amount of land into a total urban environment for 135,000. But finding enough land may be the least of Sky City's problems. Tokyo's loose sandy soil may not be firm enough to support a structure this large. Sky City would tip the scales at 6 million tons, the combined weight of every man, woman, and child in Japan. It would be the heaviest structure ever built in Asia. A risky business on the unstable soil that was once the bottom of an ocean. Sitting on sandy sediment, Sky City would be at exponentially greater risk, thanks to the single most horrifying disaster looming over Tokyo: earthquake. Tokyo's worst earthquakes wreak havoc. Even moderate earthquakes here bring buildings down. Here at the Takanaka Research Institute, engineers are looking for ways to safeguard such an enormous building.
One of the biggest questions was, can we build something this tall safely? A building that would be 3 times the size of the tallest structure in Japan.
Deep underground, this 150-ton G-force simulator reproduces the load of enormous buildings on different types of soil. This simple acrylic box will simulate the total weight of a 20-story office tower built on packed sand. As the centrifuge accelerates, it can produce 200 times the force of gravity. In this experiment, a simulated earthquake forced the model to move 1/16 of an inch, invisible to the naked eye. But the same test suggests that a 6 million ton building could shift a whopping 100 feet, enough to possibly destabilize the huge structure and bring it crashing down. So how could engineers protect Sky City and over 100,000 people from a catastrophic collapse? In some parts of the world, builders quake-proof their skyscrapers by digging through loose soil, setting their foundation on solid bedrock below. But in Tokyo, that's not an option, because bedrock is simply out of reach. Builders would have to excavate through many layers of soil before hitting rock bottom, more than 1.5 miles down, creating an 800-story basement. So Takanaka scientists experimented with an alternative to digging such a massive hole in the ground. They would drill thousands of smaller, shallow tubes and fill them with concrete. Called friction piles, they grip the earth like the fingers of a titan. And in this way, Sky City's 6 million tons of downward pressure would become its own immovable anchor. That took care of below the ground. Still, what could possibly provide enough stability for a building to rise 3,300 feet into the sky? The answer may already be under construction in Taiwan. It's called Taipei 101. When finished, it will be the tallest and the strongest skyscraper in the world. It will soar to a record-setting 1,667 feet. Though only half the size of Sky City, it may provide a proving ground for its most critical structural component, its mega columns. These muscular legs reinforce the entire structure. But strength like this doesn't come cheap. Each mega column is forged from uncommonly heavy 3-inch thick steel plate. Massively larger, Sky City's columns will require more than 500 million pounds of steel each. At a cost of $250 million per column. With 6 massive columns to build, that means a total of 3 billion pounds of steel. It would take a single mill almost 12.5 years to produce that much steel. So instead, Sky City will consume the output of a global network of steel mills. Day after day, year after year, this will be the scene as factories around the world strain to produce enough high-strength steel for the structure. Enough to build 36 aircraft carriers, 3 times the number in the entire U.S. fleet. Each 20,000-pound block of superheated ore enters the milling machinery. The metal has to go from this to this before it cools. At 2,000 degrees Fahrenheit, the raw steel is just soft enough for molding. But the water that keeps it free from impurities also robs the steel of precious heat. And after only 4 minutes in the searing crucible, the metal sheds nearly 1,000 degrees. But it also reaches its final size, a 20 by 5 foot steel plate. Each enormous Sky City column will call for thousands of plates like this. Two days later, when the plates have finally cooled to room temperature, they'll face the fire again, this time from welders' torches. There's no margin for error in assembling these mega columns. No room for even microscopic imperfection. A column could collapse, putting tens of thousands of lives at risk. To avert disaster, builders can't take chances. The weakest links in any steel structure are the welds that must forge a rock-solid whole from so many enormous parts. So an army of welders takes over. Their weapons? Torches and massive quantities of white-hot solder, burning at more than 8,000 degrees. These workers toil relentlessly to ensure that not one joint could ever fail. Donning heavy protective gear in 100-degree heat, they squeeze themselves inside the oven-like columns to finish the job. In a final step, workers shave each piece and bevel its edges to ensure a perfect fit.